Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rizky Rangga, and today I'm going to briefly explain about the 5W and 1H of aerofoil. So first of all, what is aerofoil? An aerofoil or aerofoil is the cross-sectional shape of a wing, blade of a propeller rotor, or a turbine, or a sail as seen in the cross-sectional view. It is a solid body moving through a fluid that produces an aerodynamic forces. The component of the force perpendicular to the relative free stream of the velocity, which is called lift. And on the figure down below here, as you can see, we have lift forces, which is perpendicular to the uh, free stream velocity, which is called lift. And we have drag forces on the backside of the aerofoil, which has the same direction as the free stream velocity. And on the high speed section of the aerofoil, it has a reduced pressure, and on the bottom side, which is the low speed section, it has increased pressure. So for the next one is, where does aerofoil commonly use? So aerofoil have the potential for use in the design of aircraft, propellers, rotor blades, wind turbine, and other application of aeronautical engineering. So in this figure, this is the examples of aerofoil shapes. Uh, yeah, as you can see, there is the aerofoil of propeller blade, turbine blade, and etc. So for the next one, when does the aerofoil reach its most efficient point? So it is when the optimal fluid velocity is reached. This is the optimal velocity is depend on the shape, angle, length, and the other factor of the aerofoil. So for the next question is, who is the first to successfully theorize aerofoil? So the first successful aerofoil theory, based on my quick search on the internet, is developed by Zhukovsky, which is a mathematical concept that utilizes the theory of complex variable, which is called the conformal transformation. That is, any two-dimensional potential flow can be represented by an analytical function of a complex variable. So the next question is, why do we use aerofoil? So basically, because aerofoil can produce lift and or drag when moved through fluid, uh, it can be useful because we can utilize lift or drag for many purposes. For example, like lift forces for the airplane to fly, and drag forces for braking purposes on car maybe, or the airplane itself. And for the last question is, how do numerical analysis or method related to aerofoil? So the behavior of the aerofoil can be found by utilizing numerical principle in the form of computational fluid dynamic. Uh, by using CFD to analyze the aerofoil, we can get the value of drag, lift, pressure, and others. And that is all from me. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.